Hey, you're watching Nate's Code. I'm Nate. Today we're going to be covering a LeetCode problem, but it's not about solving the LeetCode problem. It's talking about the method to solving problems in software, and I'm going to show it at three different skill levels. So I'm going to start with just a very naive approach, just trying to get the to solve the problem, and then try to add a little bit of optimizations, clean up the code a little bit, and then finally a very performant and clean approach. So I don't know Python all that well, even though I'm a senior developer. I haven't done it for like I think close to a decade since I was in college. So there's things I'm legitimately going to be looking up, but I'll also look up things just to show, hey, this is what a new a more junior developer might search. So anyway, without further ado, let's get into it. So I'm in here. Hopefully the colors and the sizing are good. I'll try to zoom in for y'all. Um, I changed this. They said K, so just to let you know, K is distance. I just like better naming. We don't need to be like mathematicians. We can actually name things more intuitively. But first, let's talk about the problem. So step one, there's two things we're gonna do before we even write a single line of code. Okay, one, we're gonna understand the problem. That's really important. You know, ask questions, get them answered. Ask a senior developer on the team. Ask your lead. Ask the business if there's other requirements. Like this is a realistic approach. What I do daily at work. And then two, we're going to actually break the problem down and not even pseudocode. I just like pseudo code, right? Like it doesn't really have to be very clear code. We don't really have to think about loops or anything. We just think about the general, really high level steps. And then we might even break down the comments a little bit deeper than that, where they're a lot cleaner to implement. And then we can look stuff up. I might not looping in Python's kind of weird, so compared to other languages, so I might have to look that up. But I'll have clean, very clear and concise like comments, steps that I know to do that I can look up like how do I translate that into code. So let's do that first. Like, what are we doing here? So first, it's like okay, contains duplicate. So something about a list of numbers with duplicates. If you look at here, it says nearby duplicate. So that's what I changed k to distance here because it's not super clear. Basically, what we're doing is we get a list of integers, and they're all positive integers. I should actually say that. Um, we're getting a list of positive integers, and we're just going to try to find if there are any duplicates in this array in this list, and if they're within a certain range of each other, right? So it says it's a bit math language. So if you like, if this was an actual task, junior developer doesn't know this, that's fine. Just ask me like, what do they mean by this? Because it says given an integer array nums and an integer k, and they don't tell you what k is. It says return true if there are two distinct indices I and j. So I and j cannot be equal in the array such that nums I and nums j, the values at those locations are equal, and I minus j is less than. Like this is confusing. Like, and ultimately what they're trying to say here is integer is k. So basically we get an array of numbers, and then we return true if at two different locations, right? Two separate numbers, not compared to itself, are equal. So there's the numbers duplicated. One is here and here, and they're within a specific range. They're a certain distance away from each other. So like 3, if we go here, which is index 0, 1, 2, 3, yep, they're within 3 because this is index 3 minus 0 is 0. Or 3, sorry, 3 minus 0 is 3, and k is 3, so it's less than or equal to 3. And if we do it the other way around, depending on how we go about it, it could be 0 minus 3, and we just care about the absolute value. So that's what they're calculating here. You can literally copy paste this whole thing, um, and we're good, pretty much, this and this. I don't know, actually, Python, if it's the and keyword or double ampersand. We'll figure it out. I would assume it's and because Python's kind of simple. So yeah, so that's the idea here. So like if we have k equals 2, this is false because even though the numbers repeat, if we have 2, there's two numbers in between them. We could do 2 steps, 1, 2, and we haven't found 2. So there's no other 2 within 2 steps of it. So step 1, let's just think about like what are we gonna do? So basically, we gotta just compare basically each number to each other number, right? Compare each number, each I want to say location, but you know what I mean. Each number to each other number. And then not the same. Or we could just use the same terminology. They say distinct indices, right? So, which we'll translate what that means later. So basically, we're going to compare each number to every other number. We have distinct indices, so that's not comparing to itself. Basically, if the numbers are the same that we're comparing, and well, basically, if basically this. In this case, you can copy code because it's basically this. I like to say then, just kind of easier. Return true. And then if we don't find any duplicates, then return false. And actually, we can put that in a new line. So something like that. So we're going to compare each number to each other number. They have to be distinct indices, so they're not the same number. And then if that's true, again, even if we don't completely understand, it's like we can just steal their code and be like, well, if that's true, it should pass. Then return true. Otherwise, we don't find anything. We're done. You know, we can think of it as looping. Then we just return false. So now that we have this broken down, we can actually translate this to code. So we'll compare each number to every other number. I don't know looping in Python very well, but I know I'll copy I and j. That's typically normal. I'm assuming I is the outer loop for I in, and I know there's a range keyword. Get the length, len, nums, and it's okay if you have to look this stuff up. That's fine, right? Because even if you don't know how to code very well, as long as you understand like steps, like maybe you've learned Scratch, which is like a visual programming language, this is perfect. Because if you break down these comments, you can just look up how to compare each item to other items in an array in Python, or how to do looping, right? How do we loop, right? And then I'm going to do for j, which is the inner loop. And same thing. So we're going through the same thing twice. And actually, we're going to do like that. And then we have to do distinct indices, which in this case just means we can translate this as if I doesn't equal j. And Python's already whining about me about indentation, and I don't know why. There. It's happy now. And you might notice I do like nested if statements. I'm not talking about efficiency here. I'm just talking about let's solve the problem. So this isn't about solving this problem easily. I'm not trying to teach how to solve this problem. You should just struggle through it yourself. I'm teaching out any problem that you're given. This is how you should approach it. Understand the problem, and then define an algorithm to solve it in just plain text, right? Plain words, whatever your native language is, English in this case, and then translate those steps step by step into code. Like that's a great way to do it. Especially, I still do it. Like this is how I actually code at work. I don't think my students believe me, but this is actually my code at work, more or less. Yeah. So, all right, and then basically we have this comment here, which is kind of weird, but we could just kind of since the comment is kind of code, we can just kind of do this and then do whatever. There we go. Nested. But basically, if that's true, oh, we got to go up and we got to go to the end and colon, right? Yep, there we go. And if that's true, so again, if these like comments are really, really close to like the code, I won't even write comments. Like I won't keep the comments just because they're so close. So in that case, that's exactly what I'm gonna do, and then I can just say return true, right? And in this case, actually, we can just do like that, and then we'll return false if we find nothing else. So I think this is right. So we keep comparing each other to each other number, which we're doing. Nested for loops. Hopefully we understand that even at a basic level. I just named them I and j like they did. Again, I don't like really single letter variable names, but whatever. And then obviously if I doesn't equal j, we're doing distinct indices, not the same number. That again, we could combine this, but that's not the point. Yeah, there. I don't know why it's always like whining. Hopefully that works. Let's run this. If it whines at me about Oh, nums is not defined. Oh, I changed it to numbers. See, that's confusing. Maybe don't do those kind of optimizations, but I just like better naming. What can I say? There we go. And then same thing. I did that wrong, but oh well. And then same thing. There we go. Numbers, 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 numbers. Wasn't even the indentation that got me. Oh yeah, and then I gotta translate this too, because I'm a dummy. So it's okay. Even I make mistakes. There we go. I should have renamed those things, but probably keeping it the same is easier in some ways, but hmm. Why is it whining? Oh, integer and list. Wow, I changed. I'm just having a field day, right? I'm not editing this out because I'm just tired. Um, and this is distance, right? We had translate k as well, so we changed nums to numbers, and k to distance. There we go. It passes. I just don't know how to name things or type right, but it's okay. So that passes. That's a decent approach. We can optimize this a little bit. So let's say at an intermediate level, and this intermediate could be you come to this conclusion the first iteration, the first time you try this, or it could just be through thinking about this, like, hey, I got it to work great. Now let's optimize this, and then that's how I would probably approach this, like just write really stupid dumb code that works, and then worry about cleaning it up. And it's like, okay, we don't need to like compare this to itself. Like, is there a way to like skip that? Because we are still checking it. And if we could just get rid of that whole step, that would be ideal. Again, not having nested if statements in this case when we're optimizing is nice because I can actually eventually get rid of this is the goal. So the goal is just do that in here, and we can actually do that. Actually, I don't know how to do that though. Python, like change index. Like, can you do that in Python? Like in C, like change the value of the index. Um. Oh, okay. This one looks like array. So they're just defining on the outside because their code didn't work. Mm. They're doing something weird, but oh, in for loop. I don't know why I was super confused with the array. Yeah. So this is what I want to do, and can I just do that? Can I just change I? I can. I could do a while loop, and even though it's accepting the answer, like I like to look at different things that I like that are cleaner. That's your original code. Okay, so this is perfect. I like this answer a lot. I'm not logged in. Um, because it's just like what we basically have, except apparently you just define the variables on the outside or something weird. I can do that. I equals 0, j equals 0. Again, I don't know if I can put this all in one line. I don't care. It works. And then all we'd have to hear is just j equals I plus 1. Hopefully that makes sense because what we can do is instead of comparing to itself, the inner loop is always going to be one ahead, right? Because we're going to compare this to this, this, and this, and then compare this to this and this. And we don't have to ever go backwards because we've already compared everything to one. So we don't have to go backwards to the previous comparison. So it saves us n steps. It's something. Saves us a check. It's a little bit cleaner code in my opinion. But yeah, that's interesting that Python does it like that. And then, yeah, see if that works. It's like one little optimization. Yeah, it works. Okay. Um, and then now let's think about at a high level, what is another algorithm? So this is a very naive algorithm. algorithm is just a set of steps to solve a problem, of course, right? So is there a way that we can do this more efficiently? And the answer to that is most definitely. Um, and so what we can do, actually, you know what? We'll just do, like I'm gonna like delete there. That's how you delete everything. Um, we'll start with steps. Actually, like that. And what's like a better algorithm that's more efficient? And we can just think of it at a high level. Like, well, we are comparing it to itself, so we're doing like nested loops. Basically, we're just comparing this to every other item in here, and then we have to do that. So we have like, oh, compare 1, and then the compare 2, and then compare 3, and then we're jumping all over this thing many, many, many times, right? In this case, n times n minus 1. So in this case, 4 times 3 is 12. So we have to do 12 steps. We went from 16 to 12, which is better, but still it's a lot of steps. It's like ideally, if we could just do it in 4 steps, is there any way to do that? And again, we're just thinking high level, anything about like data structure or anything, right? It's like if we could just walk through and be like for instance, if we get here, why do we know there's a duplicate at all? It's like, well, because I remember there was a 1, right? Like there is a 1 here. So if we could just have memory, right? Like you had another list instead of like jumping around so many times, right? We can always trade runtime complexity for space complexity, meaning just memory. So we could find a way to like remember. So if we can say, go, or basically, go through of ints, remember each int and its index, right? So we can remember its index and the number if we've seen the int before, and its index distance or range. As always, at the very end, after going through the list, return false. So we kind of have this algorithm. Might take you a while to figure this one out. That's fine. Just for time's sake. But it might take you a while to think of this hard. It takes maybe some experience. But you're like, okay, we could go through the list once, and then remember of the integers and its index. So we have to compare the index. We do need that. Remember each of those things. And then if we've seen the integer before, like, hey, I remember 1. Where was that other one? And like, well, was it index 0? And I'm like, well, I'm currently at index 3. 3 minus 0 is 3. Perfect. We're done. Otherwise, if we haven't found anything, we're done. So I think we know how to do this. And again, we can do, actually in this case, since we know we need each index and the number, I'm going to try to get the index and the number. So Python for loop index and like value, whatever. Oh, there we go. Enumerate. Okay. For, A, comma, B, and enumerate. Okay. So for index, I'm going to say number and enumerate numbers. There we go. So we have the index number, and then we have to remember. If we got to remember something, we want to initialize it out here. I'm going to call it memory. And I actually did look this up before, but otherwise, if you don't know, you can look up Python dictionaries. Python dictionaries. Right. And there's some like basics, like that's how to define a literal. I'm assuming we can define no keys. Add items, access items. I believe find items, check items. Is it truthy falsy? Check if key in dictionary. There we go. Because we're gonna have to check the key at some point. In keyword. Perfect. Okay. See, like there's things to look up, so we know how to check it. In there, we can use the in keyword. So we're looping through them, and then remember each index. Right. So we can do memory, assuming Now you might be confused, like, do we want to remember each index or each number? We're remembering the number, so the key is the number, and then we'll worry about the index later. So then it'll be the index. It's okay to get that mixed up. Like I had to think about that. I was like, okay. And then if we've seen this integer before, so we remember the number, seen this integer before. So if number in memory reads like English, and then we have to do the math thing. Basically memory or basic, and if we do it in the right order, by the way, we don't even have to worry about absolute because we're always ahead of. Again, remembering means we're behind in the index, so our index will always be greater than. So that's actually a nice little optimization. So if a number in memory and basically in our current index minus, right? So basically the distance is again less than or equal to, and this instead of k we say distance. We can actually paste that in there. There we go. And then we'll just delete that because we're just going to say return. We don't have we need a comment for basically the exact same code that we have. So we can just say return true. And then, of course, after going through the list, we can just do that. So, and actually, it's the wrong order. Again, it's okay to get things in the wrong order. I'm like, wait, I don't want to save it first. I want to know because we already have the number here. And it's like, if we found that we don't want to put it in here because it's like, oh, have we seen it? Well, we have because we just comparing the thing that we're currently looking at to our memory. Uh, so not exactly what we want to do. So actually we can do that down here. And then delete those up there. Actually, I should make sure I'm doing this right. There we go. Yeah, basically. And then again, you might, just like, if you're not a complete beginner, you might be used to doing like else, right? Like if this, else, or I don't know if they have like else if. No, else. Somewhere you can do that. They might have elif. Yeah, that has elif. I remember. You might be used to doing this or else, but we don't need to do else because remember, if there's a return, we're done. Like we're gone. So that's just one of those things. Like when you're just a brand new beginner, I remember like learning that. And I was like, oh duh, like it leaves. It's a nice little optimization. So just again, things you just learn over time. But we don't want outside the for loop. Just after the if. There we go. And then yeah, and again, don't look at the runtime because it's such a small input that you're probably not going to see a difference, but it does make a difference. Like for our first approach, we have, we basically do n times n, so that would equal, in our case, 16 steps. Right, basically that's what basically this runtime complexity is just about steps versus n times, and this was n minus 1 first, and then that was 12 steps. I knew keyboard layout, so it's driving me nuts. And then otherwise n, which is a million times better, and that's just 4 steps, which is pretty impressive if you ask me. There we go. So we went from 16 to 12 to 4, which is pretty great. Kind of by end, again, these two are basically the same runtime complexity. They're still exponential, but this is actually constant. So, or I shouldn't say constant, linear. Constant time, yeah. Linear time. So, Yeah, but hopefully that was a good walkthrough, just kind of breaking down, hey, like this is how I would think of these optimizations, what you'd be looking for. Always understanding the problem and then thinking of it at a high level before we write code. I think that's really important. So if you like this format, let me know. Like, subscribe. I am Nate from Nate's Code. Everything will be in free on Nate's, like all my Nate's Code media is completely free. I don't try to make any content, money off of this. I even once I can monetize again, I don't care to. I get paid to write code, so I don't get paid to just. I'm not an influencer. I get paid to write code, so you want to hire me, if you got a project, that's totally fine. Or you want to hire me for either writing code or one-on-one lessons or something like that, more than happy to. But yeah, all this content is free.